The cost of 1 hour of human labor in the United States, including all taxes, insurance, and social benefits, is $46. Tesla claims it can reduce that figure by a factor of 20 to 30 times using its humanoid robot, Optimus. In January 2026, the company officially unveiled the third generation and began its production at the Fremont factory, ceasing production of the Model S and Model X to free up capacity. Optimus Gen 3 stands 173 centimeters tall and weighs around 56 kilograms, which is 7 kilograms lighter than the previous generation. This weight reduction was achieved through a composite construction. The robot's outer shell is made of a special aluminum composite, while the joint housings are made of engineering plastic. The robot's hand has 22 degrees of freedom. For comparison, the human hand has 27 to 28 degrees. Tesla engineers consider the reduction of 5 to 6 degrees insignificant for performing most tasks. A key feature of Gen 3 is the cable-driven actuation system. All heavy motors are relocated from the hand to the forearm, with control transmitted through a system of cables featuring micro-rolled screw mechanisms. The force precision of each finger reaches 0.1 N, allowing it to pick up chicken eggs without breaking them and tie shoelaces. Each hand uses individual tactile sensors to determine the hardness and temperature of an object. The total number of actuators in operation is 21, 14 rotary and 14 linear, and all are built on the frameless torque motors. Rotary joints combine a frameless motor with a harmonic drive, while linear joints combine a frameless motor with a planetary roller screw mechanism. This configuration provides a transmission ratio unattainable with cylindrical gears. In harmonic drives, 30 to 50% of the teeth are engaged simultaneously, resulting in backlash of less than 1 arc minute and transmission accuracy 4 times higher than conventional systems. Joint torque has been increased by 40% compared to the Gen 2, with response time reduced to 8 milliseconds. Linear drives have achieved a transmission efficiency of 92%, with a maximum load capacity of 25 kilograms per arm. Thanks to liquid cooling of the stators, continuous operation time without overheating has been increased by 60%. The battery pack is 3.2 kilowatt-hours with a voltage of 72 volts and an energy density of 180 watt-hours per kilogram. The battery is designed for hot swap capability, and it is compatible with Tesla's charging infrastructure. It supports slow AC charging at 220 volts and fast DC charging, with charging from 30 to 80% taking about 40 minutes. The visual perception system includes 10 cameras, 2 more than the previous version. Upper and lower viewpoints have been added. The cameras work with the FSD-V15 neural network architecture, generating a 3-dimensional map of the space with positioning accuracy of ±2 centimeters in low light conditions. In total, the robot is equipped with 32 force and torque sensors, including new tactile feedback sensors on the fingertip. The Inertial Measurement Unit, or IMU, is Tesla's own second-generation design, with pose measurement accuracy improved by 50%. The computing unit consists of 2 AI-5 chips with redundancy. Power consumption when running the neural network is 200 watts, with local interference latency of less than 100 milliseconds, allowing the robot to make decisions autonomously without connecting to cloud servers. In January 2026, Tesla announced the start of mass production for Optimus Gen 3 at the Fremont factory. The plan: produce 1,000 robots per week by the end of 2026 and 10,000 per week by the end of 2027. The target production cost for one Optimus at a scale is $20,000. The market price, according to Tesla's plans, will be around $30,000. However, the current cost is estimated at $40,000. The primary cost drives are actuators and sensors, which account for 60 to 70% of the robot's total cost. At production volumes of 1 million units per year, component prices drop radically, but achieving this number is hindered by supply chain complexity. Each Optimus contains about 10,000 components, many of which are manufactured to custom specifications. Now, the majority of components for Optimus are manufactured in China. According to Morgan Stanley estimates, removing Chinese components from the supply chain would increase the cost of a single robot from $46,000 to $131,000. Tesla is forced to balance between lowering costs through Chinese suppliers and reducing dependence on them. Over the past 3 years, Tesla has built a network of partners in China, referred to by suppliers as the Optimus chain, analogous to the iPhone. This network includes manufacturers of actuators, motors, gearboxes, and machine vision systems. Some Chinese companies have already received sample orders from Tesla to prepare for large-scale production. Analysts at Morgan Stanley also noted a growing division of labor based on the principle of American brain, Chinese body. The United States leads in physical AI with NVIDIA, Google, DeepMind, and Tesla, but 60 to 80% of the hardware is manufactured in China. By 2040, forecasts suggest that the components for humanoid robots alone could generate up to $780 billion in revenue. Now, Unitree Robotics, which is based in China, has the G1, and the G1 is the main competitor in terms of price, starting at $16,000. The base version has 23 degrees of freedom, weighs 35 kilograms, and has an operating time of about 2 hours. Torque in the knee joint reaches 120 Newton meters with computing power of 100 tops. In 2025, Unitree shipped over 5,500 humanoid robots, more than any other manufacturer. Then there's Boston Dynamics. The new electric Atlas, unveiled in January 2026, featured a 56 degree of freedom, fully rotational joints, a reach of 2.3 meters, and a payload capacity of 50 kilograms. Atlas can operate in temperatures ranging from -20 to +40 degrees, and has water resistance and autonomously swaps its batteries. Control is possible in 3 modes: autonomous, teleoperated, and via tablet. In 2026, Atlas will deploy at Hyundai factories at the Google DeepMind Research Center. Production of the robots will begin in Boston immediately following the announcement. Then there's Figure AI. Figure O2 completed pilot testing at the BMW plant in Spartanburg in 2025. Over 10 months, the robot helped assemble over 30,000 BMW X3 vehicles, moving 90,000 parts and taking 1.2 million steps, which is equivalent to approximately 1,250 work hours. The results were deemed successful. The robot performed repetitive tasks with millimeter precision in a live production environment. In 2026, BMW is launching a pilot project at its Leipzig plant with the Hexagon Aeon robots, focusing on battery assembly and component manufacturing. Then, UBTECH. In March 2026, the company signed an agreement with Siemens to digitalize manufacturing, aiming for a capacity of 10,000 robots per year. Orders from UBTECH's humanoid robots in 2025 exceeded 1.4 billion yuan, which is approximately $195 million. The company already supplies industrial Walker S2 robots. Google DeepMind comes next, and it does not manufacture robots, but it creates foundational AI models such as Gemini robotics that could become the equivalent of Android for the entire industry. In 2026, DeepMind partnered with Boston Dynamics, integrating its models into the new Atlas. Now, as of January 2026, over 1,000 Optimus units are operating at Tesla's Gigafactory in Texas and Fremont. The robots perform autonomous parts processing on the 4680 battery cell production lines. They handle kitting and identify incorrectly placed components in unprogrammed environments. According to Elon Musk, Optimus's failure rate when performing these operations is lower than that of a human trainee. Training occurs through 3 channels. The first is imitation learning. A person wearing a VR headset performs an operation, and then the robot mimics its movement. At Gigafactory, Texas, starting in February 2026, operators in specialized suits record their movements, which are then uploaded to the Optimus network. The second is a sim to real. In a virtual environment, the robot practices a single movement millions of times, making mistakes, correcting them, and only then is the skill transferred to the physical body. The third is autonomous learning. If an object begins to slip in the gripper, Optimus adjusts its force without human intervention. Now, in the first quarter of 2026, Tesla will announce the V3 prototype. According to Musk, this version will be so advanced that it won't look like a robot, but will resemble a human in a robot suit. The V3 prototype will be geared not towards research, but towards industrial production, and unlike the traditional approach, Tesla plans to continuously iterate and improve its hardware even after production begins. Now, the main obstacle to reducing the price is the high cost of the joints. Even in China, where manufacturing costs are way lower, the Unitree G1 with its 23 brushless motors has a cost of motors alone ranging from $4,300 to $6,900. Each brushless torque motor is estimated to cost $190 to $285, and a minimum of 23 to 28 such motors are required per robot. Supply chain complexity comes next. 10,000 components per Optimus, many of which are custom. Suppliers warn that sourcing such high numbers of components on a scale of 1 million units per year is constrained by the slowest component in the chain. Tesla is forced to manufacture components on its own facilities more extensively than usual. As Musk acknowledged, there is no supply chain for a humanoid robot, so the company is building it from scratch. Nevertheless, the direction is set. Physical labor is ceasing to be scarce research. A $20,000 robot replaces a worker hired for $46 per hour.